oxygen there. We will later on in chapter 8 introduce what we call electron activity. Electron activity is the term that we use to describe who has a stronger ability to attract electrons towards itself. Oxygen has a stronger ability to attract electrons towards itself. Then hydrogen will have to donate its electron. Okay, so in this case, oxygen will attract electrons closer to itself. Since this is a molecular compound and not an ionic compound, there is not a complete transfer of electrons. So oxygen will bear what we call a partial negative charge. Hydrogen will bear a partial positive charge. And there's a change in oxidation number. So this is a redox reaction. Okay? Now this particular reaction, how do we recognize redox reaction? You're looking for the charges there. If you have barium chloride, sodium sulfate reacting with one another, you end up with barium sulfate precipitation reaction and sodium chloride. Now, if you look at all the species involved in this reaction, everyone has the same charge before and after the reaction. Barium, group 2A, 2 positive. Chlorine, group 7A, 1 negative, something that we talked about in chapter 2. Okay? Now, barium, 2 positive. Sulfate ion, 1 of the 16 polyatomic ions, 2 negative. So the net charge is 0. 2 positive, 2 negative. So 2 positive, 2 positive, there is no change. Sulfate ion, 2 negative, 2 negative, there is no change. Chloride ion, 1 negative, 1 negative, there is no change. Sodium, 1 positive, 1 positive, there is no change. So when you try to recognize whether a reaction is redox or not, well, you look for the changes on charges or on oxidation number. This is not a redox reaction. So not all chemical reactions are redox reactions. Not all chemical reactions involve a net transfer of electrons from one place to another. Okay? So how do we recognize the oxidation number? And this is another table that we need you to take capital M word memorize. Okay. So the 3 elements have an oxidation state or oxidation number of 0. Monatomic ions, oxidation number equals to their charge. So in this case, the oxidation number is the same as the charge. Okay? And the sum of the oxidation number, just like the sum of all charges in the formula, has to be 0. Okay? And these are the rules there. And then when you have a molecular compound like water H2O, in the compounds, non-metals have an oxidation number according to this particular table. So fluorine is always -1, hydrogen, most of the case, is +1, oxygen -2. And this is something that you need to memorize. Okay? Metals will always have the positive charge. So metals are always going to be the reducing reagent. Metals are always going to be oxidized in a redox reaction. Oxygen gas, if you have oxygen gas involved, oxygen gas is always going to be your oxidizing reagent. It's always going to be reduced. Okay? So those are that's some of the things that we need you to remember. Now take a look at page 177 in your textbook there and give you a detailed description on how to recognize the oxidation numbers there. And this is very important because without being able to identify the oxidation number, you can't assign oxidation numbers correctly. You can't identify oxidation and reduction reaction correctly. So this is something that you definitely need to pay a little bit more attention after class there on page 177. And look at those rules there, some of the things that you do need to memorize. So give you some example there. We say hydrogen normally is +1, fluorine is always -1. Now you'll ask why. We'll give you an explanation in chapter 8 when we deal with electron activity. Okay? So fluorine -1, hydrogen +1. H2O, hydrogen +1, oxygen -2. Okay? Oxygen fluoride, well, fluorine has to be -1 all the time, so oxygen has to be +2. So oxygen is not always -2. Oxygen can also be -1. When you have hydrogen peroxide, H2O2, or sodium peroxide, Na2O2, the total charge has to be 0 there. Sodium is +1, you get a total of 2 positive charges. You get 2 oxygens in there, each one will have to bear -1 charge. Okay? Hydrogen, HCl, hydrogen is +1, chlorine is -1. And the situation where the hydrogen can also be positive, again, hydrogen most of the time is positive. The situation where the hydrogen can be negative is when hydrogen reacts with metal. Metal has a stronger ability to donate electrons. So hydrogen, if combined with sodium, for example, will have no choice. Sodium will give out electron, so hydrogen will have to take in. When hydrogen takes in electron, hydrogen bears -1 charge. Now this is actually a type of chemical that we use. We call it catalysts. They're reducing reagents. They're inorganic reactions. Metal hydride. We can use that to add hydrogen atoms to different types of organic compounds. They're for oxidation reduction reactions. Okay. So here are some examples of identifying oxidation number. Remember, one of the things that we need you to be able to do in this learning objective is to be able to identify the oxidation number for the same atoms in different species here. Here's an example. Okay. We have sulfur, molecular sulfur, S8. We have sulfide ion, S2 minus, sulfur dioxide, sulfur dichloride, citric acid, and sulfate ion. What's the oxidation number on sulfur? Well, rule number 1, free elements, the oxidation number is always 0. So S8, that's the oxidation number. Monatomic ions, 2 negative charges, oxidation number is -2. So that's how we differentiate which one represents the charge, which one represents oxidation number. -2, that's oxidation number. 2 negative, that's the charge. 2 negative means you gain 2 electrons there. Okay. SO2. Well, the sum is 0. Oxygen is -2. You get -4. The sum of the oxidation number has to be 0. So X plus -4 has to be 0. X is +4. Okay? Chlorine -1. The sum of the oxidation number in a given polymer has to be 0. Chlorine -1, -1 times 2, -2. X plus -2 must equal to 0. X is +2. Okay. H2SO4. Now H2SO4 this is how you solve for the oxidation number. You get +1, hydrogen is +1, you get 2 of them. So +1 times 2, that's +2, plus X, we don't know what sulfur is, okay, plus -8. For a neutral compound, for a molecule there, the total charge has to be 0. Sulfur X, X equals to +6. For polyatomic ion, SO42 minus. One of the rules there, and I fly by that particular slide very quickly. The rule says if you have a polyatomic ion, the sum of the oxidation number must equal to the charge here. So this is X, this is -2 times 4. So X plus -2 times 4 should equal to